This is page 146 in the packet. Recall that the real numbers can be separated into rational and irrational. Rational numbers are numbers of the form n divided by n, where m and n are both integers, and all integers are rational. Irrational numbers are numbers like pi, e, the square root of 2, the square root of 3, numbers that cannot be written in this form. The real numbers are contained in a larger set of numbers called the complex numbers, which are based on the number I, the square root of -1. This I allows us to take the square root of any negative number. -9 can be written 9i squared, which factors into 3 times 3 times I times I. The square root of -9 is 3i. Five is a prime. It doesn't factor, but -5 is 5 times I times I. The I can come out, and this is I square root 5. We now turn our attention to solving quadratic equations. Remember that a quadratic function can be written ax squared plus bx plus c. Our goal is going to be to solve cases where ax squared plus bx plus c equals 0. And we're going to use a few different methods for that. This first is the easiest. If you can easily factor a quadratic into a perfect square, you can take the square root of both sides and solve. In this first example, x squared minus 4 equals 0. We add 4 to both sides. That gives us x squared equals 4. Is -2 a solution? Yes, because -2 squared equals 4. 2 is also a solution. X squared minus 4 factors into x plus 2 times x minus 2. We have x plus 2 times x minus 2 equals 0. One of these must be 0. Either x equals -2 or x equals 2. X squared equals -49. Is x equals -7 a solution to this? No. 7i is a solution because 7i squared equals -49. -7i is a solution because -7i squared is also -49, but -7 squared is 49, so it's not a solution. X plus 5 squared equals 64. Take the square root of both sides. X plus 5 equals 8, or x plus 5 equals negative 8. X can be 3, or x can also be negative 13. 3 is a solution, negative 3 is not. Any complex number can be written a plus bi, where a and b are real and I is the square root of negative 1. We call a the real part and bi the imaginary part. In this table here, the real part of 3 minus 4i is 3. The imaginary part is negative 4i. The real part of 7 is 7. The imaginary part is 0i. You see, any real number can be written as a complex number where the b is 0. 5i has 0 for the real part and 5i for the imaginary part. And this is negative 8 and I. Here are some examples of operations with complex numbers. 3i times 4i, that's 12 times I squared, which is negative 12 because I squared is negative 1. When you multiply two complex numbers, you FOIL just as you would when multiplying any two binomials. This is 2 minus 10i plus 3i minus 15i squared. We can combine like terms, but first notice that 15i squared is 15 times negative 1, so this is 2 minus 10i plus 3i plus 15, and that's 17 minus 7i. I'll do these two really quickly. This is negative 5 minus 10i, and this is 9 plus 18i plus 18i plus 36i squared, and that's going to be negative 36 plus 9 is negative 27 plus 36i. Negative 3 plus the square root of negative 9 divided by 6. Now, we'll see stuff that looks like this when we do the quadratic formula. Notice that negative 9 is 3i squared, but it can also be negative 3i squared. The square root of negative 9 can either be 3i or negative 3i. I'll write this as negative 3 plus or minus 3i divided by 6. We can factor out 3. This simplifies to negative 1 plus or minus I divided by 2.